Chris, you call yourself an EPQ, an engineering price quote solution. Tell me what you mean by that and how that's different from a CPQ solution.
Right. Yeah, appreciate that. So every one of our customers has some portion of their implementation that is highly complex, highly engineered. So really, we're uniquely positioned to be able to handle the combination of three things: configuration, engineering, and geometry. And that's what, in our minds, makes us that EPQ. So from my experience anyway, CPQs typically handle one or two of those three components, but rely upon some external system for a third component. So a simple example might be if there needs to be an iterative calculation that gets accomplished, they might reach out, a CPQ might reach out to an external application to actually perform that calc and then get information back. Or if they need to actually build geometry or create a drawing, they're actually reaching out to a CAD system to perform that task to get information back. So having that all encapsulated within KBridge makes us really unique. And again, why we call ourselves that engineer price quote.
I think now we're at the point where it would make sense to actually have a look at the solution so our viewers have a better idea on how KBridge actually looks like.
Sure thing, Frank. Here, share my screen here. So I'm going to show you two examples of KBridge in action today. This first example is a playground, and I'm showing you a finished or a far more complex configuration than I'll create for you on the fly here, just to give you a sense of what's possible, certainly, and the level of complexity. And there are a tremendous amount of rules and so forth that go in here, and I'll explain those as I go through. So let's go back here and say that we want to create something new here. And I'll go ahead and start with what really is an empty environment. So this example is a great example of everything from project level inputs and kind of the job that you're capturing down to the macro versus micro configuration of an environment, or almost nested configurators. So you'll see on the left-hand side here, there's a number of different tabs that we can open, and there's different information and even related to costing and so forth. But let's go into the configured model here. There's actually a live costing element that will update as I bring things in. I'm going to go ahead and turn off the environment for this moment here, and we're going to grab these different pieces of playground equipment. So there's everything from towers that exist here to bridges and monkey bars and all kinds of fun stuff. So let's start off with actually bringing in a tower here, and I'll bring it and just drop it into the play space here. And in doing so, it will pop open a modal for me that allows kind of that second layer of configuration. The first layer being the arrangement, the second layer being the actual, configuration. So maybe I can include a roof here, I can change the platform height and so on, but maybe we'll just leave it the way it is for right now. I'm going to toggle into what I'll just call kind of a plan view here. So I'll go ahead and grab this and move the tower over a bit. We're going to take a bridge here and again go through the process of pulling it in. What you'll notice is those diamonds there, the yellow and green ones. Well, the green ones actually allow for snapping, so I can actually relocate, reorient. There's intelligence here of what to do with the bridge itself. So let's say we're going to drop it there on the, looking down at it on kind of the west or the left-hand side of that. And then I can maybe bring in another tower. Again, I have that component that allows me to snap to it. But even if I were to drop it anywhere in the space, I can do that. Again, go through a configuration and say, okay. Now, getting a little ahead of myself here, but where it's located right now, you'll notice there's an error. There's this visual alert to the user that shows me this red space here. So essentially that means that there's a safety zone outside the tower that is beyond the edge or the boundary of the play area, and that's not permissible. So those are complex engineering calcs that are going on to accomplish that. If I grab this guy and say, okay, I want to go ahead and move that, I'll snap it to the bridge. It reevaluates and says, okay, that's all right now. We can go ahead and do that. And then maybe the last piece I'll bring in is a slide here. And so we'll pull this in. Again, it can reorient itself to where it needs to be. We'll drop it in place. And so the result is the configuration you're looking at here. So there's a number of things going on that I probably don't have time to talk through in their entirety. But all these elements, when I dropped in the slide, the barrier for the edge of the tower changed from the kind of railing barrier in yellow to the opening for a person to go down the slide that's in red. Furthermore, there are rules related to all these elements. So if I actually were to decide how I want to adjust or right click on this platform and say, you know what, I want to go ahead and put a 1500 millimeter platform in, and I say okay, then a number of things happen here. As the visual model refreshes here, you'll notice a few things occur. The first and most obvious is that the barrier for the two towers has changed to be more solid barrier rather than a bar barrier. Again, rules based. Secondly, you'll notice that the slide has actually automatically increased in height. So it knows that that slide now needs to be the 1500 millimeter slide rather than the 1200 millimeter slide. Again, all rules based. And if we take this a few steps further, you'll notice on the left-hand side, the costing has been updating accordingly. In the lower portion, let's collapse some of these menus here, lower portion, you'll actually see that I have the option to import a DWG that I can actually use as my play space. I can sketch things. I can turn environments on and off. I can actually say that I want to enable zones here. So that will allow me to see the different safety zones and overlapping of zones. And these are all code related things for playgrounds. In addition, I can change the theme of elements. So I can say that, maybe I want to have the nature theme, and that just changes some of the color and styles of wood and so forth. And then ultimately, if I go to outputs, you'll notice here that in addition to bills of materials that get created, I also can create drawings. So if I take a look at that drawing, I can actually do it one of two ways. Either I can download a drawing by a PDF, or in the lower right corner, you'll notice that I have some options here in addition to the model. I can look at the assembly drawing. So similar, what I'll show you in the next example, this shows me the plan view in this case and the recommended fall zones and minimum fall zones and the no share space. In other words, there can't be any other pieces of equipment within that outline. And then if I show also or see the elevation view and safety surface and so on. So really these drawings can be whatever the client needs to be. In many cases, in this case actually, we also do component drawings, not just the assembly drawing itself. So let's go to another example here. This is not obviously a far more industrial type example. This is a concrete vault for a pressure relief valve. And so really the challenge here is not only to get the valve assembly and so forth correct, but then also to determine the soil excavation, as you'll see in the right corner here, that get what the cost is and so forth. So simply put, I can choose from everything from different styles of materials. And again, I see that update accordingly. If I actually look at the front here on the left-hand side where my cursor is, let's say that I actually want to say that the inlet pipe is going to go from 10 inches to 16 inches. In making that change, you'll notice that a number of things occur. The butterfly valve adjusts accordingly. The pipe diameter changes, and actually the reducer to come into the rest of the pressure relief valve changes accordingly. Likewise, if I say that I want to change my frost depth to 40 from 20, it will make that change for me as well, and it will also update the soil that needs to be excavated and so forth. So if I flip over to the drawing here, again, we've talked about the capability of having these drawings in real time and the impact that can have there. So let's look at a few things. If I jump over to the bill of material that's on the drawing and I decide that, you know what, I don't need a Claval valve, I'm going to go with a Singer valve instead. As I make that change, a number of things occur. Certainly the bill of material adjusts, but then also the valve itself changed, so that the shape of the valve. In addition, if I revert back to, for example, the frost depth being 20 rather than 40, you'll see the drawing updates automatically. If I set that inlet pipe to only 8 inches rather than 16, you see that update. So this becomes incredibly powerful. Maybe one last thing, if I flip back to the model, I'll show an example of our snap drag capability that you saw in the previous demonstration. So you'll see this ladder, if I grab it, it actually knows where to go. In this case, I'll say that I want to position it on the opposite wall. So I'll go ahead and grab that guy. Again, it snaps into place. That looks good. Again, if I go back to the drawing, now I notice that the ladder is on the opposite side. And to close out this example, enter in some information for the purpose of generating a quote. And in this case, they refer to that as a report, but I'll say that we want to download a report. So we can generate outputs in Word as well as PDF. In this case, it actually takes an image of the actual configured assembly and places that on the cover page. It also includes the drawing that was generated dynamically, as well as the bill of material that is costed and so on. So just an example of the output documentation. I hope those examples make good sense and are helpful to your audience.
And what are 3 things you want people to remember about engineering intent?
3 things we want people to take away here. The first is perhaps the obvious, in that it's a solution for highly complex, engineered, configurable products. The second would be related to what I'll call visual configuration, but coupled closely with real-time drawing creation. So again, those 2 elements, the 3D visual is not disparate or separated from the 2D drawing. They are dependent upon one another. As a matter of fact, the drawing happens in real time as you do that visual configuration. And then the third is, the risk of repeating myself, really that unique combination of configuration, engineering, and geometry that I personally have just not seen within the industry under one solution.
What are 3 key benefits your customers mentioned to you that they experience when they work with KBridge?
Interesting. 3 benefits. So I'll say the first is the competitive advantage that they see, really just based upon the combination of time saved and the ability to respond to their customers faster. The second would be the ability to enable growth. And that comes in 2 portions. The first is really allowing non-subject matter experts, the sales channels, the customers, and so forth, to go through that configuration process accurately, while still allowing the manufacturer to not sacrifice the variability within their product and the complexity within their product, because many times those 2 things make them unique in their own way, give them a competitive advantage. So enabling those people to still easily configure those highly complex solutions is important. The second piece of the enabling of growth is really process automation. So in addition to the accuracy and the quality and so forth, it's really accelerating their process. So that doesn't just have an upstream impact. It certainly can impact lead times for the ability to commit to deliver a product itself. What we talked about, faster customer response. It also allows, from an engineering perspective, engineers to be laser focused on the truly custom projects. So they're not beholden to sales or, really working with sales alone and distracted by that necessarily. They can focus to where their value add is.
And what are some of the best practices that your customers should know about that make sure that an engineering intent project is successful?
The first I'll say is, I suppose, is not unique to KBridge or engineering intent. And that is as a company, if you are going to invest time, money, energy into a project, then make the project a priority. Give it the things it needs, the staffing appropriate, the prioritization in terms of decision making and timely response internally to actually get data and so forth. Again, not unique to KBridge, but experience tells me that customers don't always do that. They looking for that big red easy button, and I don't blame them, but it's not always that simple. As it relates to KBridge specifically, really where I believe that best practice comes in play is to take a look at the commonality across your products. So there's a unique aspect of KBridge that we have what are called projects. And these projects allow me to build these modular reusable pieces of information, of rule sets, of logic, and so on. So they might be related to a custom UI or a bill of material generation or some sort of CAD integration piece or automation piece that gets done. And if I, as a customer, if I look across my product portfolio, I want to make sure that I'm considering all of those aspects and what I want to get out of the system up front, because I can then build these projects and ultimately mix and match them to create what we call KBridge applications, which is just another way to say configurator. So it's really, I guess, that common piece is, people want to get sprint and get running into the project, and that's great, but it's almost that slow down to speed up. If you take a step back, look at that commonality, consider where you can leverage that. Again, my experience is something that's really powerful and unique within KBridge, the reuse and the mix matching of those projects.
Do you have some examples from existing customers that show what the KBridge solution is doing for them?
Yes. One that jumps to mind, Frank, is a company that manufactures tanks, actually, which don't sound all that configurable, but as I've learned in my career, it's amazing the variability in all of these sorts of engineered products. So with this company, their main goal prior to the project was to leverage the throughput that they had, the capacity they had within their manufacturing facility. So they wanted to be able to respond to more quotes and enter new markets, and they've been able to do that. They've actually seen an increase of 25% in the ability to expand their quote response in terms of the reduction in time. They've been able to, actually respond to 25% more quotes. And in addition, because of that, they've done two things. One is they've actually adjusted their internal team because there are fewer people now actually doing more quotes. So they reduced their internal estimating team by half, and while still improving the 25% there. But when they bring on new people, they actually noted a 15% increase in productivity for that new hire. And that's because with this, call it what you will, an expert system that guides them through the process for that configuration of the tank or group of tanks in this case, then they don't need to be as much of an expert as some of the other people who have been with the company longer.